All right, hello everyone. It's February 18th. All right, let's do this. All right, we have okay, let's do this. Meeting rooms. You're given integer n. There are n rooms numbered from 0 to n minus 1. You're given 2D integer array meetings where meetings I is start to end, means that a meeting will be held during the half closed time interval. All the values of start are unique, but the end might be the same. Meetings are allocated to rooms in the following manner. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. When a room becomes unused, meetings that have an earlier original start time should be given a room. Return the number of the room that held the most meetings. If there are multiple rooms, return the room with the lowest number. The number of the room that held the most meetings. Let me read again. N is the number of rooms. Okay, so we have these rooms, and then we have these half-closed time intervals. All right. Each meeting will take place in the unused room with the lowest number. Okay? If there are no available rooms, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. When the room becomes unused, meetings that have an earlier original start time should be given a room. So, delayed. So a meeting can be delayed. All right, so we need to know, and the start time is unique. Okay, so on the room side, we have the room. If they have an unused room, then the meetings have the earlier start. That makes sense. And then if you have two rooms, both are open, right? We'll go with the lowest number. Okay, I think I know the rules. So n equal to 2, we have these meetings. At time 0, both rooms are not being used. The first meeting starts in room 0, okay? At time 1, only one room is now used. The second meeting, okay, so both are occupied now. Now at time 2, both rooms are used. The third meeting is delayed. Time 3, so the fourth meeting is delayed. At time 5, the meeting in room 1 finishes. The third meeting starts in room 1 for the time period, because the time, okay, yeah, so from 2 to 7 becomes to 5 to 10. And at time 10, the meetings in both finish. The fourth meeting starts in room 0. Both 0 and 1 held 2 meetings, so we return 0. Interesting. Very interesting problem. Okay, I'll use the second one as the test case. So we're gonna study the first example in more detail. So again, we have two rooms. Okay, I have two rooms, and we have a bunch of, what's the n is to 100. Median length can be a lot. Okay, and then we'll start. Everyone has a different start time. Okay, different start time. So what we need, right? What we need is to so you can put this, let's say you put this into a I'm thinking about priority queue, right? Priority queue. So the first one comes out. The lowest time comes out, right? The lowest time come out. And then for these two rooms also, For these room, we need, so let's say we have one priority queue for this, and we have another priority queue for this, indicating this the end time, right? The end time. So we have two priority queues. And at the beginning, the end time, both the end time is 0, right? Both the end time is 0. So let's say this is 2 rooms, so we have 2 things, both is 0, okay? So now what we do is we pop the first, So now we have the end time is 0 and the start time is 0. So the start time is larger or equal to the end time, right? And we probably need to have the index as well. So we have this, right? So the available room, right? So the room will be a 0, 0. And then the meeting will be a 0, 10, right? Will be a 0, 10. But it means different things, right? It means different things. 0, 10 is the meeting starts at 0 and the 10. That's actually going to be the open. A room is 0 and the index. And then we have a counter, right? We have a counter to count how many times each room gets used, right? And then what do we do? And then we have this, okay, this is good. So the room, because we pop it out, then we push it back in, then we're going to change the first value, right? So now we push it back in. This is the end time. Now the end time becomes 10, right? So now we push it in, then this thing becomes 0, 1, and a 10, 0, right? And this one got popped as well. Now we go to the next round, right? We go to the next round. The next round pop out. The room is going to be 0, 1, right? Index is 1 and 0. And the meeting pop out is going to be 1, 5, right? 1, 5. And then 1 is larger or equal to 10 until 0. So I use this, we'll push it in. The next one we're pushing will be, because it starts from 1, right, and end at 5. So this one will be 5. So we push it in. Now we have a 5, 1, and a 10, 0, right? 5, 1, and 10, 0 into the priority queue. So the next round, when you these got delayed, right? These are delayed basically just means, yeah, we have to based on this, right? Based on this. So this pop out. Now my room is 5, 1, right? And now my meeting is a 2, 7. Now 2 is smaller than 5, so technically I cannot run this, but this is the next room will be available. So I can push the meeting in, but it's gonna be start from 5, right? Which means this one will end at 10. So now we have a 10, 0, and a 10, 1 in it. So next one pop out will be 10, 0, which now is a 3, 4, right? Now if it's a 3, 4, but we're going to do 10, so this one will end at 11, right? 3, 4, because the last one, so it will end at 11. So next one I push in will be 11, 0, right? And then 10, 1. And then this one's over. So now we can count how many. So do you think this will work for the second one? Well, for second one, this is the first meeting in, and then this will be the second, this will be the third, right? And then this one will start 4, but the earliest ending time is 5. So this comes out, then this meeting room gets used, and this, because we end at 5, so this one will actually end at 14. So the next one end is this, then we do this. Okay, let's give it a shot. So 2 priority queue. It's actually not even 2 priority queue, because for the meetings, we just sort the meetings and we just always go one by one, right? We always go one by one. We only need priority queue for the room, right? That's all we need. Priority queue for the room. 718, right? All right, so what we need is from this import heap queue. Okay. So what we're gonna do is heap, right, equal to I'm gonna 0 I, okay, for I in range n, and then we are going to do a counter. Okay, we do a counter from collections. For counter. And say counter equals counter. Okay, so I have this, we have counter. Now we can start, and then we need to sort. So we can say meetings.sort. Okay, meetings.sort. Yeah, it's fine because the starting one is always unique. Now what we can do is we're gonna go through one by one, right? And we just say for start and in, I'm gonna S and E in meetings, okay? For meetings. And every time I come out, and then we're gonna pop the room, right? So we're gonna say room and the room index shall equal to, maybe I can use a tuple for this. Maybe it will be easier for me to reason this, right? So we use tuple. Okay, so if we do this, that shall equal to heap q dot heap pop heap. Okay, so we pop one out, and we have the room end, and no matter what, depends if room end is smaller than, then we use that. If room end is larger then basically I need to say heap q dot heap push, right? When I push a new thing, and then this is be ri, so what do I push here? Well, it depends, right? If room end is larger or equal to start, right? If that's the case, then we're gonna just put and, right? If this, else if room end is, no, if it's smaller equal to, right? If room end is smaller equal to start, so it's just basically says I can start right away, right? If I can start right away, I will end at whatever the time I end. If not, so room will end at a later time, then it will be the room end plus your end minus the start. So that's the new end. Now we push this in, and now we say counter ri or plus plus, right? Plus equal 1. And then we push back in, and then we try the next one, 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 until we complete all the meetings, right? Until we complete all the meetings. And then we just need to find the lowest number with that. So what I need to do is I have the max count. Actually, yeah, I'm gonna say max count is 0, and then we're gonna say for I, right, in range n, And then we can say res is equal to -1. And we say if counter I is larger than max count, then max count equal to counter I, and res equal to I. Okay, and at the very end we return res. One more position dot push. Oh yeah, I forgot to put heap inside. Okay, so let's give this a shot. Is it correct? Heap push. Oh, I think heap should be the first one. Tuple is the second one. Maybe I can go through this already, right? And we just say if counter I larger than max count is equal to counter Ri, and the rest equal to Ri. All right, now we're just trying to see if there is any. Oh, that's actually not right. Yeah, you were right. This is not right because you don't know which one gets there first. Okay, so we have to stay with this. Okay, let's see. There might be an edge case I didn't consider. Okay, so now we have edge case that we need to deal with. I just didn't really bother thinking about the edge case. Now here's the edge case. Okay, so what we have, if we sort them, be 213, 312, 710, 1719, and 1819. Right? 213, 312, 710, 1719, and 1819. So we have 4 rooms. Okay, 4 rooms. So 4 rooms, we start with 0, 1, 0, 2, 0, 3, and 0, 4. Okay, now we start. First one, so this will become and a 13, right? Yeah, I'm to reread the thing. Each meeting will take place in the unused room with the lowest number. If there are no available room, will be delayed. Become unused. Meetings that have the earlier original start should be given. Okay. So in this case, this one will have a 13 and, right? Because this is the first meeting, so I have 13 and. Oh shoot, there should be 0, 1, 2, and 3. Rewrite this part. Okay, 1, 2, and 3. So basically it's 13, 0. Okay, so that's after the first round. And then we have 0, 1, 2, 3. So 0 now is 1. Okay, now next one is 3. So this one gets, so still 13, 0. This one gets 12. Right, 0, 2, 0, 3. And next one is 7. Oh, I didn't consider the start time, I think. Next one is 7. Again. Oh, I see the problem. Because someone might be over by then. Okay, yep, I see. So this one is 7. Start with 7 and a 10. So we'll end at 10. Okay, that's fine. Now next is 17. But 17, we don't do this. 17, we actually do this. All right? Ooh. that's very interesting. Okay, so basically, how do I get this to pop to the front? Because by the time 17, right? By the time 17 comes out, all of these are done. So you actually should use this one, right? You actually should use this one. No. Oh, yes, because these are end at 12. This one ends at 10, right? So by the time 17 comes along, we need to go through the whole thing. And everybody that is smaller than this, we shall reset to 0. So in this case, once we reset to 0, then it shall be 0, 2. Now 0, 0, 0, 1, 0, 2, and 0, 3. So 17 should take in here. This should be 17, 0, right? 0, 1, 0, 2, and 0, 3. Next one, 18 comes, so 18 takes this. So, okay, let me make this little change. Yeah, that is the part that I did not consider. Completely forget about this part. Okay. So, what we're saying is, as we go through the meetings, all right, for each meeting, I need to go through the entire thing. Yeah, that is the problem. Each meeting, you need to go through the entire thing. I don't think it's possible, right? Wait, what was this error? How do I see error? Huh? Tuple int incompatible with list. It works. Argument of type literal 0 and int cannot be assigned a parameter of type this in function heap push. Is incompatible with list tuple int. Oh my goodness. Because they say this is a literal 0. What? Dude, man. Well, are you saying if I use a parameter? Seriously? You think I should use a parameter? Are you saying if I do this, it becomes a parameter? No, it's still a literal 0, right? What? Oh, switch from list to sequence. What the hell? Oh, wow, this is so strict. When I can do sequence? Huh. Oh, wow, I did not know. I did not know about this. Okay, anyway, but that's not the problem. The problem is now for each new thing comes up, right? And if the top room end, yeah, whenever the top room end is I mean, if the top room end is smaller or equal to s, this is fine. We can just use this. But if the top room n is larger, right, than s, what we need to know is so are you telling me that we need I don't know, we need something, yeah, that's not really sorted, okay? So every value, it has some value in it, right? It has some value in it. But some meeting will have been finished, right? So we have some meeting, I know when it will be finished, right? We know when it will be finished. So when the current time comes up, when basically it just means this 10.2 shall be ranked higher than 0.3. So what will be the way to rank it? Are you suggesting to sort it every time? That's not gonna work. They might as well just go through the whole thing. But I don't think we can go through because n is 100. Meeting length is 10 to the 5th. If I do a OM times n, I think it will time out. I don't think we can go through the whole thing. So it needs to be, smarter than this. Okay. But if we do it this way, I don't think there's another way. So maybe we need to do something with the meetings. Right? Maybe we need to do something with the meetings. What do you mean by do something with the meetings? So with meetings, I have a start and I have an end, right? And I have a second start, I have an end. So essentially, we can, reorganize the meetings, right? Reorganize the meetings in such a way that, because this will go first, this will go, and then when this goes, right, if I know which one, because this started at 17, right, and this end at 13, so we know this will start after everybody is ending. So basically, if somebody ends, how do you know if some meeting ends? Right? How do you know if some meeting ends? Like if a meeting ends after you start, you just don't have to worry, right? It's only when a meeting ends before you start, then that room can be considered, right? That room can be considered. So this will be coming after. This will be a new one. So these two will not share, right? And then yours is 7. It's smaller than this, smaller than this. So the current smallest is 12. So this will not share. So this will be the third room. The next one is 17. And then 17, smallest is this. But it's also larger than this. So this and this shall share the same. Huh. How are we handling this? It should be the first room that is empty, right? Which means is these rooms. Now, not just the first room that's empty, is the first room that's empty with the smallest index. That is the one. So I say 13, 12, and 10. End time. This end time is 0, but I should still check it from the front. But you still need to go one by one. Right? Every value, you need to go one by one. And then you check, oh, boom, this is good. So now this I can turn into a new value. Right? This will be, this will be 19. And next one 18. Then we check this will be 18. So this one gets run twice. Right? But in this one, you just have to go through the n so many times. The question is, once we have these things, can we quickly find which one that the current one shall be? Right? How do I find quickly? Well, to find quickly, so basically we say we have a bunch of numbers. We need to find a value that is smaller, equal to the current given value, but with the smallest index. Or we can say that's that's leftmost number that is smaller, equal to the current one. Yeah, so we turn the problem into, given a list of numbers, find the first number that is smaller or equal to the current given one. Right? That is basically the problem. We need to find the first number, right? First number that is smaller or equal to the current one. But this one, how? But exactly how? I don't think we can do it. Just given the current number. If I don't do any planning, then how do you know which one is the first that's smaller or equal to this? You don't know. Right? You don't know, because you have to follow this order. So I still think the trick should be, maybe we need to rearrange these meetings. So we know, but how do you know? Well, you look at these end time. Maybe we should do a sort by end time. What do you think? A sort by end time. That is not going to work, because a sort by end time, because I have a 13, I have a 12, I have a 10, right? So these are the end time. Now a 17 comes in, right? Now a 17 comes in. And the 17 is bigger than all of them, right? Bigger than all of them. 17 is bigger than all of them, which means 17 can take the 0 position. And then the next one comes. So this. So I take this position. I can take this. What if we do, because Because I feel like this may be like a monotonic array. What do you think? So monotonic array is I come in and I use the end time, right? So we have an end time. The next one, if the next one's end time is larger than the previous one, then I pop the previous one. So the next one goes in. You are in the 0 position. If the next one is smaller, exactly like in this case, if we do monotonic decreasing, okay? If we do monotonic decreasing, look at this. If it's a monotonic decreasing, all we have is a 13, right? A 12, a 10, whatever the next one. The next one is a 17, so 7 is bigger, so I pop this, which means 17 can do this position. Oh, 17 can do this position. Oh, 17 can do this position, so 17 is here, right? And then 18 comes in. Oh, actually not 17, my bad, it's 19, right? 19, because we use end time. Yeah, we use 17 to check, but we put 19 here. And then the next time is 18 comes in. Now 18 comes in, we have position, so 18 put this. So what we're gonna do when we have like these cases. Okay, so we have 0, 10, 1, 5, 2, 7, and 3, 4. So again, 10, 5, but this one only have 2, so that's it. Next one, 2. Next one is 2 come in, but with 7, right? 2 come in we cannot do, so we need to wait for the first one to end. This is the first one to end. So we will pop this, but we don't put 7 there. We put 5 plus this, so we have a 10, right? The next one come in, right? Next one come in. Actually, next one come in is a 3, 4, right? So again, we don't have enough, so we have to wait for this 10. Right, we have it, so we say we do this 10, but this is also 10. See that? That is interesting. Oh, hold a second. We said we pop this, right? Okay, so yeah, we pop this. And now the new ending time is 10, so we'll push 10 in. But when we push 10 in, right, we push 10 in, because these two will end at the same time, so I need to keep pushing. So basically at this time, it will be 10 nothing. 10 nothing? What if it's 10 nothing, then I might as well just... it is 10-10, right? It is 10-10. Because I do this, and I push 10 in, so it's a 10-10. Okay, it's a 10-10. So the next time when we come, not enough, so I need to do a pre-check, right? I need to do a pre-check. So I need a pre-check. All the things that have the same time, they should all be popped. So instead of I have something to pop them, because we don't have anything to pop, so this one, because we start with 3, right? So the start time is smaller, so it cannot pop. So this cannot pop, right? So we just say this is gonna come in. Or maybe I can. Yeah, because this is smaller than this. I say you are starting from 10. Exactly, this I say you start from 5, right? You start from 10. And now I pop, pop, pop. So actually now it become 11. Right? Okay, let's try this idea. This idea looks promising. So there's no more heap. Actually, I'm going to delete everything. Okay, so we're going to use... I should have very high faith in this. I think this is the solution. The monotonic. Use monotonic decreasing array. So array will equal to this, okay? And counter equal to counter. I mean, technically, I don't even need to use this counter. I can just say 0 times n, so I don't even need to use counter, okay? And then we just say meetings.sort. Or if you want to save a line, and say for start and in sorted meetings, right? So we sort everything. So when we come out, we say if we have empty room, we'll use it, right? Yeah, if we have empty room. But what if? No, we don't. We always try. Okay, so we say while array. Okay. Hold on. There's a very important thing is if array. Okay, and array. This is the end time, right? It's at the end. If this end time is larger than your start time, okay, so which means the current smallest end time is larger than your time, right? If that is the case, then your start time, okay, and end time will equal to this is your start time, and end time will be this plus end minus start. So we do this. Then we say while array and array minus 1 is smaller or equal to your start time, then array.pop. Right, array.pop, because current is smaller or equal to, which means your start time can wait until it's finished. So we pop until we cannot pop anymore or array is empty. And then you do array.append your current end time. Yeah, I already update the end time. Do the current end time. And then we say count len array minus 1. Right, this is the index plus equal 1. Now, there's another thing that I didn't consider is the because I cannot keep adding, right? That's the thing. I cannot keep adding new values into it, right? I cannot keep adding. So if I hit a limit, right? If I hit a limit, I cannot keep adding more. Which means if I am filled, right? If the rooms are filled, actually, will that even happen? Will that even happen? Because I do the first one, okay, and the second one I say if array and then this is larger than me, then I always pop it. Basically, this is what it says. But in reality is if you have enough room, you shall just take it, right? In the unused room, because there is an unused room, which means this is actually not right. What we need to do is if hold on, let me think again. Now, if okay, if oh my god, if the end time, right, at the end of the monotonic array, if it is smaller than the current, right? If it's smaller than the current, then no matter what, you shall do the monotonic thing, which means there will be a meeting that's ending before your current start time. So no matter what, you should do it, right? It doesn't really matter how long, how many rooms are empty. You should always wait, because you wait, you'll get a room with a smaller number. And you don't do this, right? If you don't what we're saying is, if your current start time, which is this case, right? This case. If your current start time is smaller than the smallest end time, right? So in that case, this only happens if we don't have enough, right? If we don't have enough, which means if this and, right, and len array is equal to n, right? So we already have all the meeting room. So this is saying, right? Okay, this is saying the current start is smaller than the smallest end of all the meetings, all the ongoing meetings, and all the rooms are occupied. How do you spell occupied? Occupied, right? So when that happens, so I can start, but everything is occupied. That's when I change my start time. So my start time becomes the current smallest end time. If the rooms are not all occupied, we have a free room. Okay, we have a free room, and my start time is there are free room, and my start time is smaller than the smallest end time. So I have to start. So I don't go through this, right? So my start time is smaller, and then this one will not run because I am actually smaller than this, right? This is bigger than me. So I just add this and I do this. And at the end, what we're gonna do is return the, okay, so this I can use the same. I can say max count is equal to 0, rest is equal to -1. This is the same. It's the same stuff in range. And if counter I is larger than max count, okay, then max count equal to counter I. Why don't you just copy and paste? I have no idea. I don't know why I just write this whole thing again. All right. I have very, very high hope. Counter is not defined. Oh, I didn't call it counter. Jeez, I call it count. All right, I have very, very high hopes for this. Oh, it will be wonderful if I got this done. But the ideal of monotonic array, I think, is very smart. Very smart, right? Use monotonic decreasing array. Okay, let me write a bit more. If the current, okay, so in monotonic, actually, I like to do it here. Use monotonic decreasing, sort meetings, and then use monotonic decreasing array to keep track of the end time. If the current meeting's start time, okay, is smaller than the last end time in the monotonic decreasing array. All right, and also one more thing. This array represents, okay, this array represents the n rooms, right? The n rooms. So if the starting time is smaller than the last end time in a monotonic array, there are two scenarios, okay? Scenarios. First, there are still empty rooms, right? Empty rooms. We shall take it. 2, there is no more empty room, right? No more empty room. In this case, right? In this case, the current meetings start time becomes the same as the last end time of the monotonic array, right? Monotonic array. Then we do the most important step of popping, right? The monotonic array. We compare the start time, either the original, right? The original or the modified. We compare the start time with all the end times in the monotonic array. Right. If the start time is bigger, we pop the array because we can take that room, right? We can take that room. We keep popping, right, to find the smallest room number that the current meeting can start, right? Can start with, right? Yeah, that is basically the idea. And we keep track of the count of the number of times each room is used, right? Each room is used. So this runtime will be sort of the meeting is O(n) log n. Okay, so this part, line number 34, this is O(n) log n. And then within, I do this monotonic thing. Actually, I'm not sure how long that's going to take. It's a monotonic thing, and then we can say, actually, I'm not sure. I am not sure how long that's going to take. In fact, this might time out too. Right? Because you're adding, and you're popping. Right? And you're adding. But not every step will do this. So I don't know. I don't know amortized, like what would be the... I feel like maybe amortized is O(n) log n, because you're not doing this popping every single time. That's the thing. You're not popping every single time. You will add, right? And then you might pop once or twice. And yeah, I'll say this. I don't have a good proof when it gets this complicated. I think the amortized runtime is O(n) log n. Yeah. Not sure about this. All right, let's make sure that this one is correct first. You're so confident in this, it will be very, very interesting if this one is wrong, right? It will be very interesting if this one is wrong. But I have high hope. High hope. Great. High hope goes bust. All right, how many did we get? At least we get 63 out of 82. So must be some interesting edge cases that we need to go through. All right, that's fine. So what type of edge case is this one? So we got, I think it's sorted 0, 10, 1, 9, 2, 8, 3, 7, and 4, 6. Okay, so these are increasing and n times decreasing. Okay, very interesting. All right, so how would you do? Well, of course, in my calculation, right, start as a 10, right? So if array is not array, now, so I go 10, right? So we have 3 positions. So first I go 10, this is the array. And then we go for the next one, right? So next one is a 1. So we have this, and this is larger than this, right? Because the start is 1, and this is larger than, but len array is not equal to n, so we don't do this. So we go here. This is smaller than the current start node, so I just append n. So now we have 9. This one will be same, so now I have 8. Okay, so everybody is in. Now this one comes in. Okay, this one comes in. If array, yes. Array, this is larger than this, yes, because I start is 3. And length, yes. So I say my start shall be, so now this turns into 8, and the end, and the 8 plus and minus start. So it'll be 8, 12. No, 8, 13. No, 8, 12. Come on. What the hell? What's your problem? This is 4, right? 8, 12. So now we do 8, 12. We come here, right? So we come here, and then we start popping, because this one will be done. Yeah, that's how we planned it, right? That's how we planned it. So this one will be popped. Okay, so this 8 is popped, and then I try to compare this, but we cannot pop because this one is done yet. So we add, so now we add 12 in, so we added the end, so add 12 in. So now this we have run 2 times, right? This is 1 time, this is 1 time, this is 2 times. Next comes in, right? Next comes in is this 4 and 6. Again, we do the same thing. Ooh, what the hell? What the hell? You don't do this, you don't do the end. You don't do the start. This is the end. Dude, what the hell? What the hell? This is not start. Right? You use this to compute what the end is going to be. And you should use the end to pop this. You should use the end to pop this, right? Am I crazy? Am I crazy on this? You should use the end to pop this. Wait, hold on. Hold on. I'm confused. I confused myself. Wait, hold on. Wait, which one should we use to pop? Well, the array are the ends, okay? That is done. The array is the end. So now I have this thing. Okay, let's wind it back. Okay, let me wind it back. I think I got confused. I confused myself. Okay, I confused myself. So this is good. We use n. So now this one comes in, right? Everything is filled. So I have a new start and end. Perfect. Right? I have a new start and end. Perfect. And this is 8. Okay, so this end is 12. Right? This end is 12. So where should I put this thing? Now technically, I shall pop everything, but that's not true. I should use the start to pop, right? Yeah, it should be the start. But if I use the start, then this is no longer a monotonic decreasing array. I mean, yes, this one is wait until this meeting is over. So now it comes in, right? Now it comes in. And this is taking this place, right? And then this is taking this place. But when this comes in, okay, so I say this takes this place, so you might be 12. That's not right. Okay, you don't do 12 here? You don't do 12 here. Yeah, this is not right. What the actual hell? Right? But you need to use the start time, because you go pop in the start time and you put your end time. But now the end time is not monotonically decreasing, right? The end time is not monotonically decreasing. See, like that is, some problems right there, right? Some problem right there. Because when this one comes in, when 4, 6 comes in, when 4, 6 comes in, okay, and this has to stay here. But when 4, 6 comes in, I cannot use this, right? I need to use, when 4, 6 come in, is this, is its end time. Dude, what the hell? What the actual hell? Yeah, it's not right. It's not right because 3, 7 comes in, the end time becomes 12 for this meeting, right? This meeting ends at 12, and you are not creating a monotonic decreasing array. That's all I can tell you. You are not. Okay, you are not. So this is wrong. Okay, this is wrong. But if we can create a monotonic decreasing, or at least tell me what is the smallest end time, right? Tell me what is the smallest end time at the moment. Okay, so now the smallest end time at the moment is 9. The smallest end time. What am I coding? Oh, it's a LeetCode problem, number 2402. Just coding a solution for this. It's a tough problem because I got stuck for 1 hour and 1 minute. But I feel like I'm very close. I feel I'm very close to the solution. So all I need to, what I need is the smallest end time, right? Because that will be the first. Now that is not true. See, that is the problem. That is not true because we have that idea already because of this test case, right? This test case is not true. We can't just find the smallest. Well, it depends, right? It depends. If the smallest time, oh, thanks. So I'm going back to the priority queue idea. So in the priority queue, I have whatever value in the priority queue, right? I have whatever value in there. And if I have whatever value in my priority queue, I can always get the smallest value. Okay, I get the smallest value. It's the end time. And if the smallest value, if my value is larger than this, I can pop it. I can pop it. I can pop it. Okay. I can pop all of them. And then I put my in. Then I have my index. Okay. So in this case, I have these 3 in. And the next one, this one comes up. The starting time is 3. And I check with the smallest. It doesn't work, right? So I'll get this into this. Actually, I pop this one out. Or I can peek it, right? I peek it, and it's not good. And then, again, it's the same. If I have smaller, if we still have capacity, I need to push myself in, right? I need to push myself in, and I put my end time in it. That's perfect. Now, if I have filled the capacity, and now I have a smaller comes in, I find the smallest, okay? I find the smallest, I pop it out, and I will replace with something, I push it in, okay? And then whatever the room this one is, I will be occupying as well. So next time will be 9 pop out, and then they will be replaced with this, push it in. Okay, so that is good. It's, the thing is, if I have this thing, let's say it's not 3, 7, okay? If I have, let's say 100, okay? 100, and then I just need to pop. Okay, it will be amortized O and okay, let's try this one. So this, yeah, this is not a monotonic array, and it's not working. Oh my god, what am I gonna do? All right, I have to delete everything. I thought I have the solution. No, you did not. Okay, so I still need a heap, but now the heap starts with empty. Okay, counter is fine. This is fine. This is if heap. Okay, if heap and well heap. I do monotonic. That's not monotonic. It's a min heap. So I'm peaking at the top. And for the top, which means the smallest end time. Okay, so this will record the end times. Okay, record the end times. So this is the smallest end time is larger than the current one. Right? That's the case. And len heap is equal to, we have full capacity, right? So the smallest end, the current start time is smaller than the smallest end of all the ongoing meetings. And yeah, this is still true. Then I'll do this will be, wait, hold on, why is it not working? Okay, heap 0. Okay, and this will be heap 0 plus, yeah, this is right. So I just reset start and end, and then this will be slightly different. I'll say while heap, okay, and heap 0 is smaller equal to start. Okay, so the smallest is the smaller equal to start. When that happens, I don't do this because I need to do heap q.heap pop. Okay, so I'll pop heap, I pop heap, and then I try it again, and I try it again, and I try it again, and try it. So basically, everything which is smaller than this, I'll be popped. And once we get popped, I'll push myself in. Now, here is the thing. Here is the thing. When you pop the heap, the end times, record the, it's gonna be a tuple because I need end times and room number. Okay, room number needs two things. Okay, needs two things, which also means this should be 0, 0. Okay, 0, 0. And here, same thing, should be 0, 0. And that is 0, 0. It's two things. And here the same thing, 0, 0, right? And I will pop because this room is no longer useful, no longer useful, no longer useful. But, okay, now is the other problem. I keep popping those rooms and they have different numbers, right? They have different numbers. Then which one, which one is the one that's available to me? That's a good question. Which one will be the smallest available to me? So I need to keep track, right? Keep track of everything that gets popped, right? We keep track because the rooms that's the rooms that has been occupied, right? When they get popped, I need to know the smallest that gets popped. Right, the smallest that's getting popped, which means I need to keep track the current smallest room. So min room min ri shall equal to, we start with n, that's fine, and this will be I don't need to keep track the n, but popped ri shall equal to this. Okay, and I say min ri, let's try it, equal to minimum the min ri and popped, I think I spelled popped wrong, I think it's a double p, right? It's double p. Okay, right, now we get this. Now we keep track of what is good. And remember, if the length of the heap is not n, which means we have more capacity, and then we can just add a new thing into it. But what is the new thing? Well, if it's not capacity, then the new thing added will be the new room, right? Think about it. If it's not capacity, then we always add the new room. That is absolutely correct, right? That's absolutely correct. So we go through this whole process. We're trying to find, actually, that's not n, okay? That is not n. That shall be len heap, right? The current length of the heap. The current length of the heap. And if it's, if the length is n, then this one will be n. And because it's n, we have reset the starting time. So this will, at least one of them will work, right? One of them will work. And if this one doesn't run, then this will be smaller than n, which means we still have capacity. And if we still have capacity, then if this one doesn't run, then I can still work, right? So we do blah, blah, blah. And this line need to change into heap queue dot heap push, right? We need to push a new thing. So I need a heap first, and then this new thing, okay? This is something we need to push in. What do we push in? So first we need to push in the end, which is the current end, updated end. And then we need to push in which room, which is min ri. We push this in. And here we need to change this into min ri plus equal 1. And then these two are the same. All right. I'm not as confident as last time. So I'm probably not gonna write as much. So go back to the min heap idea, right? Min heap idea. But we are also taking advantage of the idea of using the size of the heap, right, to decide whether there is any room left, right? Unoccupied room left. Unoccupied room left. And we do the popping, right? We do the popping as well when the current start time is not smaller than the smallest end time, right? End time among the occupied rooms. Also, we need to keep track of the room number of the popped, right, elements, right? Elements. A popped element represents a room, an unoccupied room, right? Unoccupied room. So okay, my current concern is, as we pop, and a new thing comes in, would it be that, okay, this is my concern, because would it be possible that I occupy room 1, 2, 3, like let's say I have a room of 4, and I have room 1, 2, 3 open, and 1, 2, 3 occupied. Then I comes in, then I say I'm occupying. Yeah, would that be possible? See, that is a thing. I don't know. From my understanding, it might, right? What if the room 0? If room 0, well, if we have something that is the current one, right, that it gets popped, then we'll take it, right? We'll take it. We'll take it, right? We'll take it. And all right, we will take it. Oh, hold on. If the current one will take it, okay, so 0 is still in there. Would it be a situation where, you know, 0 is popped, but it's not taken? That's not possible because 0 is the smallest room ID. So if we pop 0, 0 will definitely be occupied, right? Which means if we pop something, the smallest amount of popped will get occupied. So what if, but the pop is based on the end time. So 0 gets popped, the 0 gets occupied. That's fine. What I'm thinking is an array, which is not fully filled. Okay? Would it be possible that an array is not fully filled and it's the 0 position not filled? Would that be possible? Well, how would it be not fully filled? Well, it's just the 0, 1 gets out first. Well, if it gets out first, you will be the first to get popped. I can't easily find a counter argument, so let's just put in here and see if one of these fail. If it fail, we'll take a look. All right, they all look good. Let's just submit it. Let's see if this one works. Yeah, does not work. God damn. Screw me. Screw me. Man, this is... Woof. Okay. Yep, that's pretty tough. That is pretty tough. All right, it's kind of late. It's 3 a.m. in the morning. My goodness. I think what I'm gonna do is I want to understand this, why this one's wrong, and I'm gonna log off. We're gonna continue this tomorrow. It's fine. It's fine. I've done this type of thing before. You just, you know, I try not to read the solution. I think what I'll do is just sleep on it. Think about like why this one is wrong. And exactly what went wrong. 34, 40, and 38, 44. Oh, you're missing 30. Oh, Jesus. I'm missing 17, 38. Okay. Then 34, 40. Then 38, 44. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. Did we solve more than before? 76. Okay. Looks like we are in the right path. Okay. The first one solved 69. The second one is 63. And this time is 76. Okay, what happened? All right, if in our idea, we have 27, 0, that's the first one. And then this is 6. And yeah, that's basically added in, so 29, 1, right? And this is 7. We have capacity. We have 4 capacity, so this one's 14, right? 2. This is in room 2 because none of these are open. Now this 17, okay? So it comes in. Don't do this. So minute R is 3. So while heap, and this is the top, is smaller equal to, yes. So now minimum room would be 2. Okay, so this one gets popped because the 17 is bigger, Right? Minimum room may become 2. And but this one, the next one is 27, so it doesn't work. So now I push in, is the current end is 38, and then 2. Okay, so 2 gets so if we have count, so 1 1, 2 gets 2, right? 2 gets 2. Right, next one is this 34. 34 comes in. Again, it's not fully occupied, so minute runs is 3. And the first one is this. Right, first one is 27. And it gets popped. Right, 27 gets popped. Now it's become 0. And then 29 gets popped. Okay, now we have 0. Right, so 34 is and is 40. So now we have push in 40 and 0. Right, 40 and 0. So 0 gets 1 count as well. Next is 38. Okay, so 38 comes in, and oh, I see. 38 comes in. Don't do this, but we do this. We popped this. But we shouldn't pop this, right? Because we still have capacity. Shit. Why do you pop it? Exactly. Why do you pop it? Well, the reason is there is still capacity, right? There is capacity. Because we have 1, right? 1, we have capacity. If we don't have 1, then we do this. So we need another way to keep track of the smallest unoccupied room so far, right? We need a way to keep track of the smallest unoccupied room so far. How do we keep track of the smallest unoccupied room? Another heap. Another heap. Holy crap. Another heap. Another heap. I use another heap to keep track of the unoccupied room. So every time when I pop, I push the stuff into the other room, into the other heap. Therefore, when I do this, right? So before I do it, I check. I do have to check. And then I intend to do it, but I also check what's the current unoccupied. If the current unoccupied is smaller, the room number is smaller than the current, the one that I'm about to pop, then I don't pop. Instead, I use this. Did you see what I'm saying? Did you see what I'm saying? So I have 2 heap. One for the end time, right? For the end time and occupied room. And the other for the unoccupied room, right? Okay. So I have 2 heaps. Then this is the occupied room. This is good. I like this. But for here, I don't do this. I do not do this. What I do is I run this, but when I'm about to pop, I check the unoccupied, right? I check the unoccupied, and I compare the one I'm about to pop and the smallest unoccupied room number. If the one I'm about to pop has smaller room number than the smallest unoccupied, and I pop it. Okay? and I just keep doing. But whenever it's not, then I stop. Then I stop, which means if the unoccupied room is, oh my god, this is if the unoccupied, again, if the smallest unoccupied room number is smaller than the room number of the smallest end time, God, right? If that is the case, then I stop and I'll come out and I use that. Okay, hold on. I might be able to. I said I'm gonna end, but I think this might be. All right, I need to change this. Okay, this is end times. Unoccupied. Okay, so this record the room numbers of the unoccupied rooms. Okay, so of course that doesn't start with this. It shall start with list of range n, right? That's where we start. Counter is fine. This is all right. So we don't do heap. We just say, okay, we probably should do this heap end times. Okay, so next we'll change to end times. It's fine. Now this is different. Okay, so this is end. Oh, jeez. So this is again end times, and end times this is smaller than this, and unoccupied 0 must be larger than end times 0 and 1, right? If these are the case, then I will pop the heap, because if I pop it, I get a smaller room number. But I don't do this. I don't do this. What I do is I'll say unoccupied dot, no, heap push. Okay, unoccupied will push the current pop this. Okay, then we go again, we check, blah blah blah. Once we AND, okay, once we AND, what we're gonna do is heap push the end time, and this is going to be popped. Heap pop. We're gonna pop an unoccupied. Okay, here's the question: will the unoccupied be empty? It is not likely. Well, it is likely. It is likely to be empty, because when you do this, this might be empty. So we shall be and not unoccupied, or right, like if this is empty, if unoccupied is empty, or occupied is not empty but it's larger than, yeah. So we have these two situations. Oh, hold on, what did you do? 11K. So if these two situations, oh my goodness, this is end times, right? Then we'll pop. And this, oh, I need to, oh my goodness, hold on. Ri shall equal to heap q dot heap pop unoccupied, right? And then this will delete, this will be Ri, and then this shall be Ri. Okay, what do you think about this? Okay, so a min heap for the end times and room number. The keep track of the room that will be empty next. Main heap for the room numbers, for the unoccupied room numbers, to keep track of the room that will be occupied next. Like that. Okay, let's just take a look again. See how this one goes. My God. So let's put this one in. And I hope all the others are still correct. All right. Run it. How'd this one go? No. All right. All right. That is about as much I want to do now. Damn, it's pretty hard. All right, I'll call it. I'll call it for today, and we'll have to keep working on this tomorrow. Lordy, this is tough. And I'll analyze this tomorrow. Yeah, we'll analyze this tomorrow. All right, I'll see you guys tomorrow for this one. Adios.